Okay. Next up, we have Tatjana. In this presentation, Tatjana will give us an idea of how existing and new research comes together for her to give one big picture of what autism is and why some crucial new findings seem to fit in where a puzzle piece was missing. Thank you for joining us, Tatjana. Tatjana Peskir is mom to a daughter impacted by autism. Her daughter's cord blood was destroyed en route to Duke, which is why she and her husband set a large international case against one of the biggest CB banks, CryoSave, in motion. The criminal case against the CEO of the company is still ongoing in Geneva, Switzerland. Once upon a time, she graduated from university specializing in the management of public institutions and later went on to work in consumer protection, helping shape public policy in that area. Today, she is a full-time autism mom, learning a new thing every single day, enjoying the progress her daughter is making and helping others find the information they need. Thank you very much I know you're not even local, so thank you so much for taking the time to meet with us today.
Thank you for having me here, and I'm really grateful to Enrique. For some reason, I did not see this research by a Bulgarian university. I'm really interested to learn more about that. So thanks to Enrique for telling us more about that. And I just want to say, because me and Enrique actually have some parallel points made in our presentations, I didn't know what he was going to say, and he didn't know what I was going to say. So with that, I'm just going to start here, and I'm just going to share my screen with you. So let me just share my screen here. Okay, so can you all see my screen? So can you all see my screen? No? Share? Well, here we are. Okay, now it's gonna happen. Okay, so this is my personal theory of autism, and I'm just a parent, so I'm doing the best I can, reading 6 or 7 years worth of research in the past 6 or 7 years. And here we go. So we have obviously the obvious, we all know that we have inflammation in the autistic body. We have an obvious implication of the immune system. So much research points towards that. But we also see, that we have metabolic, functional, and structural differences in every system and on every level, from the cell level then upwards. Now we have, research coming out of Hong Kong showing that the retina has a different structure in autism. Wherever you poke, you will find something in every organ, in the hormone system. And to me, the question was always, what can be causing this situation where everything is wrong? And both, is it genetic? That's not really a good enough answer for me, because we would have to find either one gene that covers all these different things that are wrong in an autistic body, or we would have 100 genes, and that's not going to be useful. And also, I do not know if we are there in our knowledge about genetics to have any meaningful therapies developed from that in our lifetime for autism. And when I heard about the cell danger response theory, I started falling in love with it, because it would encompass so many things and provide so many answers to so many questions. But there was one thing that was bugging me, and that is that we have a lot of research pointing out the problem of either overpruning or underpruning in the autistic brain. And so much has been written about it. It has been proven to be a big issue. And that, how could that also have to do something with immunology? Is neuroinflammation enough to affect pruning? But then again, it happens so early in life. These were the questions that were, preventing me from looking at the cell danger theory and saying, that's it. Inflammation is everything there is. So then at the Synchrony conference, which happened this last year in December and November, we had a presentation by Lisa Bullinger from Princeton, which I found really enlightening and which for me was the missing piece. She talked about moonlighting markers, which would be immune-related cells doing other jobs in the brain, where we didn't even know that they exist in the brain. And then she also posed the question, are these actually immune-related cells, or are they and proteins, or are they simply proteins that we first found in their, function in the immune system, and then we also found them in the brain, but now we call them immune proteins, whereas they could also just be called proteins doing various different jobs around the body. And she had focused her research on a protein called MHC1. The way she came to this was by looking at genes related to pruning, and especially they were looking at genes related to pruning to see if there was something they could find there, and they found that the MHC1 family of genes was related to pruning, and their usual function in the immune system is sort of to sit on the outer wall of the cell like a billboard, proclaiming what's wrong with the cell, if it's an infection or a cancer situation, so that T cells can come and kill this cell. But in any classical medical book, what you will find is that MHC1 proteins will be found in every cell, every nucleated cell of the body, except neurons. So they were wondering, how could this type of protein be associated with brain development? Is it an error in our, analysis? But then, when they looked at imaging and antibody analysis of ground-up brains of mice, it showed that MHC1 was enriched in synapses. And the less MHC1 you have, the more increased neuron connectivity, and vice versa. So there is a lot more to this research, and you can look that up. Though I think Lisa Boulanger hasn't published something new in the past few years, and something new will be coming. But it's really a remarkable piece of research to me, and something that is adding that missing piece. How can pruning be also related to the immune function? And I found it significant for me. One other thing that left a lasting impression on me from the past year was the closing panel discussion of the Synchrony conference, which consisted of the people you can see here on the slide, so that I'm not going to be reading all their names. And also there's Matthew Anderson, who Enrique mentioned just a few minutes ago. And what I had hoped to do was, in the app where we could follow the web conference, you could ask questions for panelists ahead of their time of presentation. And I posed this question several hours before this closing panel, hoping that I would steer the discussion in this direction. My question was, I think all these days of presentation we have had clearly show that autism is an immunological disorder. We still need to learn a lot more about what kind of immunological disorder, but I think it's extremely clear that it is one. And I was asking, all these experts, can we please work on getting it reclassified from a psychiatric disorder to an immunological disorder? Because it would change how children are evaluated, how they are treated. Everything would change if we had that on a very broad scale. And I actually managed to steer the discussion in that direction, and it was obvious that all the experts were on the same page. And I felt that there was a momentum to change this going forward, obviously not in the next 5 minutes or in the next year, but I could finally see that this would be possible in the next few years, maybe. And it really gave me hope for the things that we can do, because obviously we here read all this research and we try to access whatever we can for our children, but on a broader level, this really needs to be decided by the science and the scientists. But I could see the momentum there, and I just hope that this is the future that we will see going forward. And now I would just like to discuss some things that happened in the past year, which I found really interesting. We obviously have stem cells and a lot of development there, both on the scientific and practical level. On the scientific level, we have now, the scientists are working on new homing mechanisms so that stem cells deployed in a body go to the place where we want them to go and not be, mostly used up in the lung and other organs where we never meant to send them. On the practical level, back to the scientific level. We also have just, I think, a few days ago, an article in the Jerusalem Post came out, which I couldn't find the scientific paper related to that. But the Israeli scientists had managed in a small group to replicate the Duke protocol. But another thing they did was just some imaging studies a year and 2 years after the treatment. And they found that there were more synapses formed, significantly more synapses formed in the brains. And obviously, they also had across the board statistically significant improvement in the group, which was, I don't know if I said that, just 60 children. But the other thing, they also had, of course, a subset of children that improved dramatically. So that is, a good development, and especially the thing with the imaging of the synapses. Again, another moment where we can see black and white that therapy is doing something. And the practical developments in stem cells therapy is that we now have so many more clinics around the world offering MSC cells, umbilical cord blood, a mix of the two. And I just love seeing that, serious companies and serious university clinics offering hope and treatment to parents, because there is a subset of children for whom stem cells will be of help. The other thing we have is Suramin and the trial in Africa by Pax Medica, which was offering 3 monthly doses of Suramin, unlike the one that was trialed in the US. And they had good results. Obviously, what probably everybody wants to know, and what I wanted to know as well, was, are these results sticking after these 3 doses? But the data is still out on that. I contacted Pax Medica, and they said they would be releasing a bigger data set sometime this year. There was also an interesting article in the New York Post, which I found very relating to our illness, though it was talking about schizophrenia. And it was an article about 2 cases. One of a man in Japan who had gotten schizophrenia and was treated for that, but then he also got cancer, and he got a bone marrow transplant, and that bone marrow transplant cured both his schizophrenia and his cancer. And parallel to that, there is a case in the Netherlands where a man who had cancer got a bone marrow transplant from his schizophrenic brother and cured his cancer, but he got schizophrenia. So this is one of those examples where we can clearly see that what is happening on the mental and the psychiatric plane is and can be immune related. I don't know if we can find a more obvious example than schizophrenia and the bone marrow transplant. So I found that significant on a broader level. And there was just something that sticks out to me generally in the science of autism and immunology, and the connection between mental disease and immunology. I come from, like it was said about me, from a management background. And to me, in a common sense perspective, this idea that has lasted so long in science, that the brain and the immune system are separate, doesn't make any sense. Because if we are driven by evolution, driven by our drive to survive, and we have this brain which is driving our body and controlling our body, it would be completely impossible to have it separated from the main survival function, which is defense. So I do not know of any organization that we can look at where defense and management would be separated. It is just completely impossible. And as a parent of an 8-year-old child with autism now, I have to say that looking at the landscape of science and also practical applications today versus, to where we were 8 years ago, I am so awestruck by the many great options we have in testing, in treatment, in imaging, in networking and discussing things like that in forums like this and in conferences. And I feel there's a really great time ahead of us. Obviously, that could be because also my daughter is improving. So, I also have a very subjective view of that. But, this is really a great time for autism research and the application of autism research. And I'm really happy that we have come this far in these years since I have been in this area. And I would also just like to stress what also was Enrique mentioning, and I mentioned in this presentation as well, sort of a call to action. We really need to work however we can on getting this disease reclassified into an immunological disease. It would change everything. It's the single biggest thing we can do. I think it would just change the landscape completely and change the lives of our children and the children to come. So this is what I had to say. I will just stop sharing my screen. A second. Okay. So here I am. Hello. I don't know if I went over time.
No, that was wonderful. Thank you so much.